So after Uranus, this cosmic billiard ball is gonna shoot past Neptune and ditch our solar system, turning into an interstellar spaceship in the vast universe. Humans have always been curious, itching to explore and see what's hidden out there. For over 40 years, Voyager 2 has been all about that exploring spirit and hunger for info. But get this, Voyager 2 just found something so serious, it's turned around, pulled back by some unknown force. What did it find, and what does it mean for the secrets of the universe? Tag along as we go beyond the edge of the universe to check out Voyager 2's new, scary discovery. Back in '65, the universe saw an awesome moment in space exploration. Gary Flandreau, one of NASA's brilliant minds at the Jet Propulsion Lab, was put in charge. His job? Figuring out the path for a spacecraft heading way out to the gas giants, Jupiter, Saturn, Uranus, and Neptune, just waiting to spill their secrets. Armed with a pencil, because this was before computers ruled everything, Flandreau got to work. His smart calculations paid off big time, changing how we explore space. Peering into how things move in space, Flandreau spotted a rare alignment of the gas giants happening in the late 70s and early 80s. It's like the planets were lining up to form a beautiful necklace with Earth right in the middle. But this wasn't just a pretty sight. It meant spacecraft could use the planet's gravity like a slingshot, zooming from one planet to the next, saving time and fuel. Flandreau's math showed not only could we get to Neptune faster, but he also discovered gravity assist, using a planet's pull to boost a spacecraft's speed. The way Jupiter, Saturn, Uranus, and Neptune line up is what makes this possible, creating a sort of cosmic highway. NASA jumped on this chance, showing how quick and ready they were for a space challenge. Launching Voyager 1 and Voyager 2 wasn't just a big deal for space exploration, it was a win for human smarts and never giving up. What's really amazing is how long the Voyager spacecraft have lasted. They were made tough, with tools that could handle space for decades. Launched in the late 70s, their stuff still works, even if some of it's getting old. As Voyager 1 and Voyager 2 keep trucking through space, they're like ambassadors from Earth, carrying golden records with sounds and images of life here. They're a time capsule, a snapshot of humanity waiting to be found by aliens out there. Their mission has gone way beyond what anyone expected, giving us awesome info about the outer solar system and beyond. Every day, data comes back, teaching us more about the universe and why exploring space is important. Even though it was only planned for 4 years, these interstellar pioneers went on a trip that blew past that. Launched in '77, the Voyager spacecraft proved they were tough explorers, going beyond what was expected and changing the books on planetary science. As they flew through space, Voyager 1 and Voyager 2 gave us a peek at the outer solar system like never before. We got killer close-up shots of Jupiter's crazy storms, Saturn's amazing rings, and cool details of their moons. From the icy waters of Enceladus to the volcanoes on Io, each find showed a wild and complex universe, pushing what we thought we knew about planets. Voyager 2 really made history by being the first to get close to Uranus in '86. It showed us this mysterious ice giant with an atmosphere of hydrogen, helium, and methane. Just 3 years later, Voyager 2 did it again, passing by Neptune and giving us our first close-up look at the distant blue planet and its weird moon Triton. But maybe the coolest thing about Voyager is how long it's lasted. Even after flying over 14 billion miles from Earth, it still talks to scientists, sending back important data about the stuff between the stars. These probes, about the size of an old VW Beetle, have smashed all expectations and keep pushing our understanding of the universe. The Voyager probe's awesome trip started with a risky move, getting a gravity assist from Jupiter. No one had ever tried that before. This showed how innovative the mission was, making the Voyagers true leaders in space exploration. Getting through all that space wasn't easy. The wiggle room was tiny, measured in minutes, showing how exact everything had to be. It took a lot of planning to make sure every part of the trip went smoothly. As the probes headed towards Jupiter, they went 10 times farther from Earth than Mercury. Their path took them through the tricky asteroid belt, filled with space rocks that could have wrecked the mission. Going through the asteroid belt was discussed a lot back in the 70s because no one really knew how dense and what it was made of. But the earlier Pioneer 10 and 11 probes made it through okay, proving it could be done. This showed how tough the spacecraft were and made way for the Voyager missions. But the Voyager still faced challenges as they went deeper, with new mysteries and chances for discovery. With just 69 kilobytes of memory, not even enough for a small picture today, the Voyager spacecraft had a huge problem. They had the same memory as a tiny piece of what your phone holds. It's amazing how smart the engineers were who built them. These brave explorers counted on their onboard brains to get through space. Imagine trying to find your way across a huge ocean with just a compass. That's what these spacecraft were doing before the internet. The data they collected was stored on old 8-track tape recorders, the kind your grandparents used to listen to music in their cars. It's crazy to think that old tech was responsible for the awesome things Voyager found. Even with limited stuff, the Voyager spacecraft talked to Earth using a transmitter as powerful as a fridge light bulb. But with giant antennas, they sent and got signals across space. Think about being so far from home that it takes over 18 hours for a message to arrive. That's what Voyager 2's signal was like. Every bit of data, every picture, every whisper from these travelers had to go so far before reaching scientists back home. As the Voyagers went farther, they had to deal with interference from all the human-made stuff, radios, TVs, and cell phones. Despite all this, the Voyagers have beaten the odds and keep surprising us with discoveries. Their trip through space has changed our idea of the cosmos and the unknown places beyond our solar system. One mystery is the Oort cloud, a group of comet-like things held together by the sun's gravity, stretching halfway to the nearest star. It's far away, and the Voyagers are slowly heading there to see if they can figure it out and understand what it does for our solar system. But going through interstellar space, where the solar wind stops, is an easier place to explore first. Here, the heliopause is the border between our solar system and interstellar space. It's where the sun's influence fades and the stuff between stars starts to take over. At first, people thought the heliopause was around 50 astronomical units away. This made scientists give more money to the Voyager mission to learn about this important boundary. But as the spacecraft went past this mark, they didn't see the signs they expected, which caused debate and made researchers rethink how space travel works. Also, the Voyagers have given us cool data on what makes up interstellar space, teaching us about the environment beyond our solar system. This has changed how we see the universe and opened new doors for exploration. As the Voyagers keep going into the unknown, they show humanity's endless curiosity and drive to learn, pushing boundaries and uncovering secrets, one find at a time. One of the things scientists really wanted to confirm when entering interstellar space was a jump in energetic particles, galactic cosmic rays. These often come from supernova explosions and travel close to the speed of light. While they're a danger to spacecraft and astronauts, the lower energy particles are blocked by the sun's magnetic shield, protecting our inner solar system. As the Voyager spacecraft kept going into the interstellar medium, scientists watched for the rise in cosmic rays and changes in the magnetic field, affected by gases and stars in interstellar space. The idea was that this field would be different from the one in our solar system. But when Voyager 1 broke through the heliopause, the outer edge of the heliosphere, on August 25, 2012, scientists were confused because there was no shift in the magnetic field. Fast forward to November 2018, and Voyager 2, like Voyager 1, sent back data that puzzled scientists. There were no big changes in the magnetic fields, challenging theories and raising questions about interstellar space. These missions have expanded our knowledge and highlighted the possibilities of exploring beyond Earth, inspiring future exploration. But the current models couldn't explain this when Voyager 2 arrived. The solar wind, charged particles from the sun, was at its strongest. This hinted that the heliopause might be farther than thought, maybe past 120 astronomical units. As the Voyager probes ventured into the unknown, where the solar wind meets interstellar space, they found cool data, including small changes near the heliopause, influenced by the interaction between the heliosphere and interstellar space. Despite these changes, the Voyager probes saw little change in the magnetic field, raising questions about when they'd leave the heliosphere. Experts debated whether the probes were in the heliosphere or interstellar space, with evidence pointing to increased cosmic rays and plasma density, suggesting a move to a new cosmic area. Understanding the heliosphere is like figuring out a goldfish bowl from the fish's view. To really get it, we need a probe outside, giving us a better look at this area. Amid fast technology, the Voyagers are relics of space history, built with smarts. These pioneers use vintage tech from the 1970s, with instruments made to handle space for decades. Despite the time, they still work efficiently. The Voyagers use heat from plutonium to make electricity, lasting over 50 years. This has allowed them to send data back to Earth. NASA's careful management of the Voyager's power shows how much they want to get the most out of these spacecraft. Each decision balances preserving tools and extending the mission. Despite problems like low power and temperatures, the Voyagers keep surprising us. The magnetometer and plasma science tool are expected to last because they're kept warm inside the spacecraft. Other tools are on a 13-foot arm. If all goes well, scientists could keep the missions going until 2030, but power is the key. Despite challenges, the Voyagers will keep moving forward. Voyager 1 will pass Proxima Centauri in 16,700 years, and Voyager 2 will do the same 3,600 years later, circling the Milky Way for millions of years after our Sun dies. These tough spacecraft will be there, mostly intact, unlike our planet. Maybe they'll send one last message, but it won't be by radio, and no humans will be around to hear it. The Voyager story shows human exploration and curiosity, pushing the limits of time and space.